Hi there everybody, today we're going to look at translations. Alright, so when we're looking at translations, translation means effectively move. So we're looking at moving shapes, and it's really a case of how you do translations, how you describe translations, but essentially it is just moving. So we're not rotating it, we're not reflecting it, we are literally moving it. Okay, so if I actually translate the shape right 3 and down 4, we would literally lift up the shape, move it right 3 and then move it down 4. Okay, and of course it's about accuracy more than anything else and making sure we don't make those mistakes. So we count a point, so we go right 3, and of course we count a point and down 4, and we just make sure we've got it in the right place before we kind of move on, essentially. All right, so you can always check your answer by counting from any corner, which we just kind of mentioned, so that's what you need to do. You can use tracing paper to help you slide the shape, but I think in most cases I don't think you need to. You can just take the points and move them. Right, a good way of describing translations, and you'll see this more and more and more, is what we call using a vector. All right, not a coordinate. Don't be confused with a coordinate. It's basically a vector. So what you've got is two numbers. The top number represents it going left and right. Okay, and your bottom number represents up and down. All right, so that's important to recognise, is that top number is left and right, and bottom number is up and down. And you can see from the diagram, which has kind of appeared over here, is that if it's positive, then it goes right. If it's negative, it goes left, and if it's positive, it goes up, and it's negative, it goes down. All right, the same way a coordinate grid would work. All right, so let's have a look. So 6, 3 means, well, hopefully you can say this before I do. It just means top number means 6 right, and the bottom number means 3 up. All right, 6 right and 3 up. What about minus 2, 8? Well, the minus 2 means 2 left, and the 8 means 8 up. Left 2 and 8 up. And then 0 minus 3. Well, 0 means it's not going left or right at all. And then a minus 3 just means down 3. All right, so you could just write down 3, I suppose. Okay, I don't know why I put left 0. Could write 0. It doesn't matter, it's just down 3, isn't it? Okay. Right, so if you have to translate shape A by vector 3 minus 4, so the idea of saying, now I understand what this means. So this 3 means right 3. So 1, 2, 3. And the minus 4 means down 4. So 1, 2, 3, 4. Then my corner of my shape is there. I'm going to leave my cursor there for a second while we kind of move it. So hopefully it kind of touches my cursor over here. Please, please, please. Now, yeah, and there you go. Okay, that's where it's kind of gone. All right. So that's the translation around a vector. 3 right and 4 down. Okay. So describing them, well, so far I've kind of introduced you to the vector, but of course the other side of this is me basically giving you a shape that's been moved, and then you telling me how that's moved. All right, so on here, so if you're asked to describe the transformation, again, what they are not saying to you is that it's moved. All right, so they're not saying it's been translated. They're not asking you to describe the translation. They're saying describe the transformation. So has it been rotated? No. Has it been reflected? No. Has it? What's the other option? Has it enlarged? No. So my only option here is just literally moved. All right, so actually saying it's translated is actually going to get you a mark in the paper, because they want to know that you recognise that it's been moved and nothing else happened to it. So translation is the first bit. All right, and then I'm going to try and count. All right, so from A to B. So what did we do? We went 2 right and 4 up. All right, so if we're going to write that as I should in vector notation, then I'm going to put 2 right and 4 up, and I am going to say, like I said, translated by the vector. All right, and it's important you say translation or translated by, and obviously then put the vector. All right, if you're ever unsure about vector notation, hopefully you won't be, but of course, make sure you get the words right, and then obviously if you're confident with the vectors and you're happy with what you're doing, then obviously use that instead. All right, so that's what I'd probably suggest. Get confident with actually what's going on and make sure the words are right first. If you then get confident with the vectors and you know you're not going to make a mistake, then use the vectors after that. Okay, so that is translations. So please do go to maths-school.co.uk and obviously consolidate and do some practice on it. But obviously feel free to come back to the video if you need to. Thanks for listening.